Behold graphs. We have a graph that shows how potential energy changes with distance. Now remember, when we talk about U is the integral with a minus of the force of dx. Then if I take the derivative, F is going to be du by dx with a minus. So when I look at this, what is it? It's the slope. So remember when we talked about force, if I look at force versus distance, then area is going to be my work done by force, and then the opposite of change in energy, right? Now, in this case, I have how energy changes with x. So if I take the slope of that graph right here, the slope is going to be 2 over 0.5, and it's going to be 4. However, remember, if u increases, that means that, think about gravity. If my gravitational energy is increasing, I'm moving this way, but gravity is going that way. Think about force of spring. If I am stretching the spring to the right, my force is to the left. So in my graph right here, my potential energy is increasing, which means that the force is in the opposite direction of displacement. So if my slope is 4, then I'm going to graph negative 4 newtons over here until 0.5. And then it switches. And the slope now is negative. It's not the area anymore. It's the slope. And in this case, it's negative 4. So the slope is negative 4, meaning that I'm going to reverse to 4, and it's going to be up here between 0.5 and 1. So my change in energy per distance with a negative sign would be my force. So this would be 4 newtons. And that's how you solve number 34.